In video 4 of lesson 1 for section 3, we begin our look at the second method for the addition of mixed numbers symbolically. Once again, we will only use numbers and symbols in completing the addition calculation. So for method 2, we will change all mixed numbers to improper fractions. We will then add all fractions, whether proper or improper, by finding a common denominator, if we need to, and adding numerators. We will then reduce the improper fraction to simplest form, if necessary. Take that resulting improper fraction and convert it back to a mixed number. If you're given mixed numbers in your question, then your answer should also be a mixed number, unless told otherwise. And of course, this process will become clearer when we complete a few examples. So here we go. Let's add the following. In A, we have 2 1/5 plus 1 3/5. I notice that my denominators are the same, so I know that's going to make it a little bit easier as we go through this question. But for method 2, the first step in our process is to change our mixed numbers to improper fractions. Now, how you decide to change these mixed numbers to improper fractions, I guess, is ultimately up to you. So you could go through the visual process of drawing out, say, rectangles or circles and piecing it together that way. You could take your 2 1/5 and say, well, that's like a 5/5 for one whole, a 5/5 for a second whole, and then we got another 1/5. Add up the numerators, 5, 5, and 1 is 11 over my common denominator, 5. And you could do it that way. However, I'm going to encourage you to use the little process that I showed you in a previous video, whereby we start with the denominator, multiply by the number of wholes, add on the numerator, and then put whatever you get all over your denominator, which in this case is 5. So 5 times 2 is 10. 10 plus 1 is 11. So 2 1/5 is 11 over 5. Plus, start with the denominator 5, multiply by the whole number part 1, which gives us 5. Add on 3, we get 8 over our denominator, 5. We have a common denominator here, so I just put it down, and 11 plus 8 is 19. That's our improper fraction. We check to see if it's simplest form, and in this case, yep, 19 over 5 is indeed simplest form. But now we have to change it back to a mixed number. So what we're going to think about here, well, how many full groups of 5 can you get out of 19? Well, I know that 3 groups of 5 gives me 15. 4 groups of 5 would be 20, but I don't have 20. I only got 19. So 3 groups of 5 it is. And then I have 4/5 left over, because 15 is 4 away from 19. 3 4/5 would be your final answer. If you need to, in between here, you could look at 19 over 5 and say, well, that's a 5 over 5 plus another 5 over 5 plus another 5 over 5. So you're figuring out the number of wholes, and then you'd be left with a 4 over 5. So these 3 5 over 5 pieces, that would give you your 3 wholes. So if you need to put in this step, feel free, not a problem. In B, 3 5, 6 plus 2 1/6. I notice my denominators again are the same here for my proper fractions. Okay, let's get at it. So we got a 6 times 3, add on the 5. That'll give me 23 over my denominator, 6. Plus 6 times 2 is 12, add on the 1 is 13. That gives me a 13 over my denominator, 6. Common denominator, put it down. Now, 23 and 13 gives me a 36. This is pretty cool. 36 divided by 6, we should know that 6 goes into 36 exactly 6 times. So that actually gives me 6 wholes and nothing left over. So obviously this would be simplest form. In C, 4 1/7 plus 5 over 14. Now if we look at this one, Couple of things you may notice right away. Number one, our denominators for our fractions are different, but that's okay. We know how to deal with that. And you may also notice that there's no whole number part in front of the 5/14. But again, that's quite all right. So what we're doing here is adding a mixed number with just a proper fraction. That's quite doable. So 4 1/7. So I start with my 7. 7 times 4 is 28, plus 1, 29. So I have 29 over 7, plus there is no mixed number to change to an improper fraction. So I just put down my 5 over 14 again. My denominators are different, and we have learned, of course, that we need a common denominator to add. So my LCD for 7 and 14 is 14. So I rewrite that first fraction with a denominator of 14. Just copy down the second one because it already has a denominator of 14. So 7 times 2 gives me 14. And if I double up 29, that gives me 58. Now, 58 over 14 plus 5 over 14. Copy down my common denominator. Add the numerators. 63 over 14. There's our improper fraction. Can it reduce? Yes, indeed it can, because 7 is the GCF for 63 and 14. 63 divided by 7 is a 9. 14 divided by 7 is a 2. And by reducing this improper fraction, it makes it a lot easier now to convert to a mixed number. So now I want to know, how many full groups of 2 can I get out of 9? Answer, 4. 4 groups of 2 gives me 8, so I have 1 left over. 4 1/2. Final answer. Then in D, 1 1/12 plus 5 1/3. Well, let's see. 12 times 1 is 12, plus 1 is 13. So that's 13 over 12. Plus 5 times 3 is 15. Add 1, I get 16 over 3. My denominators are different. I have a 12 and a 3, but I know that the LCD is a 12. So first fraction, I leave as is. Second fraction, I write an equivalent fraction for 16 over 3, and that will give me a 64. Numbers are a little bit bigger here, but that's fine. We'll deal with it. Put down that common denominator, add up 13 and 64, and you will get a 77. And 77 over 12 is in simplest form. So we just have to go and convert it now to a mixed number. So how many full groups of 12 can I get out of 77? Well, 12 times 6 is 72. So that would be 5 twelfths remaining. So 6 and 5 twelfths would be my answer. And now I'd like you to proceed to the next video in this lesson.